Welcome to another exciting morning at Chem 1105 with your host, me, Dr. White. All right, a couple important things. Yesterday, I went through how to use a scientific calculator and using scientific notation in your scientific calculator. If you're having trouble with this, come to my office hour. If you're having trouble with this, tomorrow after class, which is a lab, I'll stick around and I'll help you. There's been yet to be a calculator I haven't figured out how to use, especially since the manuals are all online. That helps a lot. So that's one thing. Two, if you're having uh, problems with the Beyond Lab Z, come to my office hours. They start tonight at 6 and I'll go till 7:15. I'm thinking of changing them, but let's see what happens. And I'm about ready to sneeze. Hold on. Ah,
Bless you.
thank you. I could use all the blessings I can get. If you haven't figured out, yes, I'm religious. Not that it matters, but thank you. He's been looking over at me and after me for a long time. But anyways, again, my office hours are from 6 to 7:15. Remember, it's a different Zoom login that's on the website in Blackboard, and it's also in the syllabus. If not, email me and I'll send you the link. But please come if you need help. All right, don't forget the lab we did yesterday, the density lab, is due tomorrow. Keep up with the labs because they're 10 points and they add up real quick and they're not that hard either to get your 9 or 10 points. All right. Let's get going. Yesterday, we were talking about, or not yesterday we did a problem set, but on Monday, we were talking about where are the electrons and where are they? And let's go back and review that. And the electrons are in the electron shells. And the electron shells have very complex names, shell 1, 2, 3, 4. And the number of subshells, remember each shell has electrons that are approximately the same distance and approximately the same energy from the nucleus. The nucleus is the center of the atom that has protons and neutrons, and all around it are the electrons and electron shells. Now, each shell has subshells, and subshells are the area where electrons have the same energy and are the same distance from the nucleus. Now, shell 1 only has one subshell, shell 2, 2, 3, 3, 4, 4, and therefore, and that's the shells. Now, if we look at the subshells, they have letter designations S, P, D, and F. And S is the lowest energy, P is the highest. It goes from S then to P, and this means S is less energy than P, than D, than F. I'll never ask on a test, but a couple years ago, students said, what do those letters stand for? And I'd forgotten, and I looked it up again, and sharp principle, diffuse fundamental, and those come from the atomic spectra, which we talked about. When you heat up an element, it gives off light, and you can separate that light into different bands or frequencies with a prism. Now, when we look at the subshells, and these really should be lowercase, but don't worry, I won't tell if you don't. But subshell S, the maximum number of electrons is 2. P, the max number is 6. D, the max number is 10 electrons, and F, 14. And again, S is the lowest energy, F is the highest. Now, as I mentioned before, a couple of years ago, I decided, you know something, I should really be testing a student's knowledge of chemistry, not how good their memory is, even though you do have to still memorize things, but I cut way down on the memorization. In this course and a few others, organic chemistry, know that, you got to memorize. And with that, if you look at important information, test number 1, this file is in the lecture folder of Blackboard. These are things, this will be on the last page of test 1. Ooh, speaking of test 1. All right, time out for another public service announcement from the management, me. A week from tomorrow will be test number 1. We'll cover chapter 1, appendix A2 and A4, and chapter 2 and chapter 3. I will be putting out between now and sometime tomorrow morning before class an announcement, and you'll get an email with the details of test number 1, how many pages, how many questions. I think I'll also put down, I have a few multiple choice, and how many points. It will be 100. And therefore, it'll help you, and I'll talk about that tomorrow. But be sure to do the practice problems. Speaking about practice problems, next Tuesday, I'll do chapter 3 practice problems because I'm going to finish chapter 3 today. And you may not have time to do them by tomorrow, but by Tuesday you should. Also, next Tuesday, I'll be doing my world famous, I don't know about it, I haven't received any awards yet, but my world famous review for the next test. And that would be test number 1. Once I started doing this years ago, students said it really helped them. And if you haven't figured out, I want my students to do well in my class. So definitely come for test number 1 review next Tuesday. Oh, I have one other thing, I almost forgot. This tomorrow after lab, totally optional, I will teach anybody who sticks around. It takes about 10, 12, 15 minutes at most, usually about 10 to 12 minutes. I will teach you the method how to totally eliminate test anxiety. And students have gone from being D and F and barely C students to high B and A students. And you can use this method for, well, let me take a look. Oh, thank you, Rain. But anyways, I've been doing it for a long time, reviews, but I'll be teaching that method, how to eliminate test anxiety. And good news, you can use it in other classes too, and it really works. All right, so the question is, and I talked about orbitals, which I'm not going to put on test. Where are the electrons? And we use what's called the electron configuration, which is a statement of how many electrons an atom has in each of its subshells. Remember, a subshell is designated by a number, the shell number, and its subshell letter. So an actual subshell is both a number and a letter. So, see board for examples. I got to get to work. Sometimes I'll use the word give. So sometime in the future, you'll see where you've been at, are going to be asked a question, 3 points each. Give or draw the electron configuration for A, oxygen. Well, what do you do? Well, the electron configuration deals with all electrons. Well, how many electrons in oxygen? Good question. How do you find out? You go to your friendly neighborhood periodic table, which I put a copy in the syllabus folder, and I think I'm going to put one also in the lecture folder or another place, and I'll let you know tomorrow. But anyways, if we look at oxygen, and let me ask thumbs up, people. Do you see the periodic table on the screen? Thank you. You find oxygen, first thing you have to know is what's the chemical symbol oxygen? O. Then how many electrons? The atomic number tells you how many protons and electrons. In this case, 8. So we now know oxygen has 8 electrons. So we have 8 electrons to go. The first shell is what? 1. And the first subshell is S. 1s is the actual name for the first subshell in 1, because it's both a number and a letter. Now, if we go and look at important information, test number 1, we can see shell 1 has 1 subshell, and that's S, 1s, and you can only put 2 electrons in. And I'm going to do that now. And you do that by superscript to the right of the letter S, 2. Now, 1 has 1 subshell. We filled it up. So now we have to go to shell 2, which has 2 subshells. What is the first subshell in 2? It's 2s. Any s orbital, we can only put 2 electrons in, and I'll do that. Well, 2 plus 2 is 4, but I've got to get to 8, so I've got 4 more to go. Now, if we look at important information, test number 1, we see shell 2 has 2 subshells. The second one, if S is 2s is the first, the second one is 2p. How many electrons max can we put in any p orbital? 6. How many do we have to go? Well, let's go back. I forgot. No, I didn't really. And we already have 4. So 8 minus 4 equals 4 more electrons to go. The second subshell in 2 is 2p. Remember, a subshell is designated by a number and a letter. How many electrons can we put in any p orbital? 6. How many do I have to go? 4. Oh, they'll fit in. And I'm done. And that's how you do it. You fill the first shell, which has 1 subshell, S, 1s, and any s orbital, maximum of 2 electrons. Then the next shell is 2. Now remember, you start with the lowest energy and then move down to the higher energy, which is why we started with shell 1. And then when you have different subshells, you fill the lowest energy, S, and then P, then D and F. Remember, this is a secret. It's my secret gift to you. As I mentioned yesterday, if we look at the periodic table, which I have on the screen, I will only hold you responsible for the elements 1 through 20, hydrogen through calcium, for electron configuration. What that means is you only know how to do the S and P orbitals in the different shells. You won't have to learn all the exception rules, and that's my gift to you. Shh, remember, it's a secret. And since Dr. White likes to share the fun, why don't you try this one? Draw the electron configuration for sodium. Let's go to the periodic table first. How many electrons does sodium have? What's the chemical symbol? Na. Remember, it's an alkali metal, and it's right here. How many electrons does it have? I'll give you 5.2 seconds more to figure that out. 5.1, 5.17, 5.189. Time's up. And the answer is 11 electrons. And I'll give you the following to look at. And it's your turn. Draw the electron configuration for sodium. And remember, if you're having difficulty, always feel free to ask in my class questions or ask for help, because there's no such thing as a dumb question in my, somebody's already got it, I think. Looks good. Aren't you proud of yourself? And when you're done, give me a thumbs up. If we were in a classroom, I could see your faces. And I'd also say, when you're done, look up and smile. But since most of you have your web camera off, Dr. White's going to use some good old chemistry guilt on you. I'm a chemist. Don't you want to make me feel good? Turn on your webcam. All right, let's get moving forward. I think everybody's just about done. Everybody done? All right, let's get going. Now, if we go to my whiteboard, which is named after me, not, we already figured out sodium has 11 electrons. What's the first shell? 1. How many subshells does it have? 1, and that's 1s. How many electrons can I put in there? 2. How many subshells does 1 have? 1. Well, I filled it up. So I have to go to the next shell. And how do you know what's the next shell? Remember, this is the lowest energy. This is the highest energy. And we always fill lowest first and then go down. Same thing with the subshells. This is the lowest energy. This is the highest. And we always fill the lowest first and then go down the list. So you do shell 1 first, which has 1 subshell, S, and then go to shell 2, which has 2 subshells, if we need them, S and P. And let's go look. So the next shell is 2, and the first subshell in 2 is 2s. Remember, a subshell is a number and a letter. And therefore, how many electrons can we put in any s orbital? 2. Well, am I done? No, I only have done 4, and I got to get up to 11. So how many subshells does 2 have? 2. The second one is 2p. And how many electrons can we put in any p orbital? Well, you don't have to memorize that because it's on important information. P, I can put in 6 electrons. If you haven't figured out, I already know these, but you don't have to memorize them. So I've got 4, I need 7 more, so I can put 6 in there. This is 2 plus 2 plus 6 is 10. I have to go to 11. Therefore, 11 minus 10, I've got 1 more electron to go. How many subshells does shell 2 have? I don't know. Let's look at important information. And the answer is 2. Well, I filled them all up. So now I have to go to shell number 3. And what's the first shell in shell number 3? 3s, which has a maximum of 2 electrons. But do I need 2 electrons? I don't know. I forgot. No, I didn't. I have 1 more to go because right here I already have 10. Next shell is S. The first subshell is 3s. And how many electrons can I put in any s orbital? 2, but how many do I need? 1. I'm done. 1s2, 2s2, 2p6, 3s1. Ooh, that was a mouthful. And that's how you do electron configuration. And it's only numbers and letters. Now, there's something called an orbital diagram. I'm going to do something interesting right now. I'm going to launch the poll. And the question is, are you done? Ignore that question and think of the question, are you reading the book? Which you don't have to, but I'm just curious. And I'm going to relaunch it. And the question really should be, are you reading the book? And it looks like most of you aren't, but a few of you are. And if you look, I'm following what's in the book, but I'm going to skip stuff. And in the book, there's called Orbital Diagram, and it's a statement of how many electrons an atom has in each of its orbitals. Orbital is where you can put 2 electrons. Example, S subshell has 1 orbital, 2 electrons. Each orbital is 2 electrons. Therefore, any p orbital has 3 subshells. I'm not going to do this, and I did in the past, but there's more other things I'd rather spend time on. And if you notice on the slide, this will not be on any test or the final exam. Now, the question you should be asking is, Dr. White, how come you're only asking us to learn up to, remember it's a secret, to 20 calcium for electron configuration? What about the rest of the elements? Well, it turns out there's something more important. Now, I'll be teaching later on when there's a chemical reaction, you make things, 2 atoms come together, and outside the nucleus are the electrons. And what forms the bond to hold them together? The electrons. And if you think about it, you're bringing 2 things together and you've got the electron shells. What's the first thing, electrons that come in contact when you're bringing 2 atoms together? And that's the outermost electrons. Those are the most important electrons, really important. And let's talk about those right now. Jada, what do you want me to go back to? Do you want me to go back to the whiteboard or the lecture slide? Which one is yes? Because I can't read minds yet. Is this the one? Tell me when you're done. And I do this one on a whiteboard on class. Before I erase it, I ask, has everybody got this down? Excellent. So the question is, what are those outermost electrons? And they're called the valence electrons. And this is the important stuff, more important than learning all the rules and exceptions for electron configuration. What are the valence electrons? The valence electrons are the electrons in the outermost energy levels. Another way of saying that is they're the outermost electrons of an element. Oh no, it's subtle Wednesday. Really subtle. You should know what are the valence electrons. And the easiest way to remember it is they're the outermost electrons of an element. Those are the ones involved in chemical reactions, which is the fun part of chemistry. Now, how do you figure out how many valence electrons? Remember, valence electrons, the outermost electrons of an element. Well, it says the group numbers at the top of the column of the periodic table are equal to the number of valence electrons that each element in that column have. And this one, I'll never ask you where do you find it, but you better know how to use this. And if you notice, even on the slide, I gave a big hint. Know this. Is this important? Uh-oh, I'm going to do a generation gap thing. You bet your sweet bippy it is. For those who have never seen Laughing, that's where that came from. If you've never seen the program Laughing, that's sad. Go look for it. I think it's on YouTube, some of the skits. Goldie Hawn and a number of other people are fantastic. Great comedy. Anyways, the group numbers, what are those? At the top of a column of the periodic table equals the number of valence electrons each element has. Now, this slide, just some important things to think about. I won't ask the valence electron generalizations, the representative elements, in other words, the elements in the same column of the periodic table have the same number of valence electrons. The number of valence electrons for representative L is the same as the Roman numeral or the standard numeral periodic table group number. Now I'm going to show you this in a second. And this is important, which is why I have it highlighted in yellow. The maximum number of valence electrons is 8. So if I ask you how many valence electrons such and such, you put down 10, it's going to be wrong every day of the week, every hour of the day, because you can only have 8 valence electrons. Oh, look, it's valence electron practice time. So let's do some practice. Now, does everybody see the periodic table on the screen? Thumbs up. Thank you, thumbs up, people. Now, this is the one you'll be using for the test. And I found out about a year and a half ago, maybe a little longer, a number of my students didn't know Roman numerals. That's something we got taught, I think in second or third grade, we were taught the Roman numerals. But because of that, I wrote down the numeric numerals. So if we look at the first column, and now, even though the family name alkali metals does not include hydrogen, for valence electrons, it does. And how many valence electrons does hydrogen have? Well, you look on top and in red, the number 1. Underneath is the Roman numeral I, which is 1. How many does lithium have? 1. How many does potassium and sodium have? 1. And therefore, all members of the column, the number on top tells you how many valence electrons those members have. Now, if we look in the second column, that's Roman numeral 2, which students didn't know, so I put the red 2. Magnesium and calcium have 2 valence electrons. Now, let's go over to my favorite, carbon. How many valence electrons does carbon have? And you see the Roman numeral IV, which a lot of students didn't know. So I wrote both. First, I did it in pencil. I said, let me do it real big so you can see it easier. The number 4, and carbon has 4 valence electrons. And if we look at the noble gases, neon, helium, argon, krypton, all have 8 valence electrons. So I'm going to let you try one. Everybody, how many valence electrons does nitrogen have? Your turn. Time's up. Valence electrons, the outermost electrons of an element. Nitrogen is N. You don't use the atomic number. You look at the Roman numeral. If you don't know your Roman numerals, V is 5. I have it in red. Nitrogen has 5 valence electrons. Ooh, let's do a good one. How many valence electrons does bromine have? Your turn. Time's up. Bromine is Br. The atomic number doesn't tell you valence electrons. The number at the top, VII in Roman numerals is, as you see in red or this one, 7. Therefore, bromine has 7 valence electrons. Real quick, how many does chlorine have? Time's up. Chlorine, Cl, has the same as bromine, 7. So does fluorine, so does iodine. Oh, let's do another one. This is a real stinky one, but how many valence electrons does sulfur have? Time's up. Sulfur, chemical symbol S. Nope, it's not the atomic number 16. Look at the top of the column, VI, that's Roman numeral 4, and I have it in red too, 6. So like oxygen, sulfur has 6 valence electrons. Oh, let's do one more. How about calcium? Remember, calcium is good for strong bones. How many valence electrons? One of your colleagues asked about the activation code for Beyond Lab Z. You have to purchase that. If you look in my syllabus, I have a link to the COD bookstore where you can purchase the activation code from them. And I got sidetracked by a question, so I better get back on track. I am calcium. How many valence electrons? It has 2. I'll tell you what, anybody having questions about Beyond Lab Z, see me today right after class or in my office hour tonight, especially if you're having problems with it. Probably my office hour, I can spend more time with you. But anyways, that's the valence electrons. And in my mind, can you see that? In my mind, oh, that was awful. Oh, bad humor day. But anyways, in my mind, the valence electrons are the most important electrons. Those are the ones involved in holding atoms together to make molecules like what you're breathing right now, oxygen, nitrogen, and those are the electrons that are the big, very important ones, the most important. Remember, you should know, 1, what are the valence electrons? And the answer to that is the valence electrons are the outermost electrons of an element. How do you determine how many valence electrons an element has? You look at the group numbers. That's the numbers I was showing you. The numbers at the top of the column of the periodic table tell you how many valence electrons each element in that family or column have. And we just did that. Oh no, guess what? We finished chapter 3. As of this moment, I've covered everything that will be on test number 1. In case you missed it, my test, every question on my test, except for your name, your name, put down your name. Actually, that's a question, but except for your name, every question on my test, I have covered the concept behind that question at least twice, usually a lot more than twice. This Tuesday, I'll go through chapter 3 problem set. I don't have a problem set for chapter 2. Isn't that much that you can't just figure out on your own. And I'll also do my world famous review for the next test, test number 1, on Tuesday. Students really say it helps. All right, it's time for, oh, I gotta do this. It's a new chapter time. And this new chapter won't be on test 1, but it will be on test 2. And during the summer and also fall and spring, we'll start new material before the test. But this way, you've had plenty of time to practice before the test. I always then before, I don't do, remember I teach by my golden rule, and I don't finish up a day before the test. That's not fair to you, but it's new chapter time. And what is this new chapter? It talks about special things of atoms that you should know about. I thought I had it open. I don't, so I had too many things open. All right, everybody see chapter 4 on your screen? Thumbs up, people. Thumbs up, people. Wake up. Thank you. Again, Zoom lights it. All right, there's two parts of chapter 4, and the first one deals with chemical bonds. Time for a real bad humor joke, and you can groan. No relationship to James Bond. But like I said, real bad joke. Oh, that was. But anyways, what's the chemical bond? Before we talk about that, let's talk about Lewis structures. And Lewis structures were developed by Dr. Lewis. Surprise. And quite important. Now, what's a Lewis structure? It consists of an element symbol and one dot for each valence electrons. If you haven't realized that we're not dealing with the DNF, the valence electrons are really an S and P of the different shell subshells. Now, how do you do a Lewis structure? Place one electron on each side of an element symbol before doubling up, putting a second electron on each side. This is very important. With a Lewis structure, place one electron on each side of the element's chemical symbol before doubling up, putting a second electron on any side. Oh, look, it's Lewis structure practice time. And we'll do this. And I better show you how to do this. Let's do sodium. And on a test, you would be asked, not in red, and I would do this, which now I'm secretly also testing. Do you know the chemical symbol for sodium? And the answer is Ni. Now, Lewis structures are only for valence electrons. And how do you find a valence electron? You go and look at your friendly neighborhood, not Spider-Man, but periodic table. Sodium, Na. How many valence electrons? 1. And how do you do that? I didn't want to... You have the chemical symbol and you put one dot. Now, this would be one example. This would be another. This would be a third. and this would be a fourth. Which one is right? They all are. The sodium has one valence electron, and you use a dot. Now, if we go to, let's do magnesium. And the first thing is how many valence electrons. So if we go to our periodic table, I'm going to let you find out first how many valence electrons does magnesium have. Hopefully you learned your chemical symbols. It's Mg. And the answer is Mg is right there. You go to the top, either the Roman numeral or the number in my periodic table in red, 2. So magnesium has 2 valence electrons, and we write the chemical symbol, and you put 1 on each side before doubling up. And there are other ones I could easily do. There are many variations. This would be another example. Now, Lewis structures, you put 1 on each side before doubling up. If you were to do this, it's wrong. And because you don't double up until each side has 1 dot, which is 1 valence electron. If I look at the clock, oh no, it's time for a 5-minute break. I'll see you at 9:55. And with that, I'm going to take a break. Don't forget, I'll be back. All right, come on. There we go. Time to start again. I love my whistles. I think they love me too. All right, welcome back, everybody. Now, one of the things I should have done earlier today, and I forgot, bad Dr. White. Does everybody know what this is? A couple semesters ago, I had a student who was from China, and she didn't know what this is. And when you were a little kid, I don't know if your parents did it, when they weren't really mad at you, but you did something wrong, they go, shame, shame on you, you're bad. How about this one? Oh, this person's nuts, crazy. But anyways, back to what I should have done. I didn't ask, have all of you been successful in getting into Beyond Lab Z? So what I'm going to do, because Dr. White forgot to do it earlier, is I'm going to send out the poll again. And instead of the question, are you done? Pretend, have you logged into Beyond Lab Z? Yes, you have. No, you haven't. And I appreciate if you answer that. Have you been able to log into Beyond Lab Z? All right, looks like the majority of you who've answered so far have. Now, listen carefully. Best time, because I've got to teach after our class. I don't have that much time of a couple minutes after today's lecture, but the best time is tonight at from 6 to 7:15. If you're working then, let me know and we'll find another time and I'll help you out to get into Beyond Lab Z. If you have a very, very old Mac, some of them don't work with that, but it's got to be real old. I had that happen to one student last semester. But anyways, be sure to log in because you have to do lab 1, which is due tomorrow. All right, let's get back to valence electrons. Valence electrons are the outermost electrons of an element, the most important ones in my mind. And the question is, draw the Lewis structure. The Lewis structure for an element, later on we'll talk about for a compound, but for an element, you put one dot on each side before doubling up. Now I've got a bunch here. Let's do oxygen. And the question is, draw the Lewis structure for oxygen. Well, the first thing you have to know is Lewis structure deals with valence electrons. How many valence electrons does oxygen have? Well, there's your friendly neighborhood periodic table. And why don't you figure out, I'll give you 5.8 seconds to do that, how many valence electrons oxygen have. And the answer is, here's oxygen. It's not the atomic number. It's either the Roman numeral VI, which if you don't know the Roman numerals, that's 6, but I also put it in 2 different colors. I did it even larger in red so you could see it. Actually, another student did it in the black. And I said, oh, that's too small. Let me do it larger. And I did. So oxygen has 6 valence electrons. So what do? Well, write the chemical symbol, and I'll give you about 20 seconds for you to draw in the valence electrons on your own first. It was more than 20 seconds, but I won't tell if you don't. All right, so I have 6 valence electrons. You start on any side, and each side gets 1 first. Well, I've got 4, I've got 2 more to go. How do I know that? 6 minus 4 equals 2. Now, organic chemists like to double it up this way. 1 on top and 1 underneath. But if you're not an organic chemist like Dr. White is, you could have also done this or any other combination where 2 sides have 2 dots and 2 sides have 1 dot. You never have more than 2 dots on a side. I've seen students do something, and again, this is wrong. I better go to red. They've done something strange like that, and I've seen someone put 4 dots on one side. No, it's wrong. You only have max 2 dots on a side, and you put 1 on each side before doubling up. And let's do one more, because these are good. They're fun, and they're good for your grade. Oh, wrong color. What I have on? Yeah, let's do. Why don't you draw the Lewis structure for bromine? And you'll need a periodic table. So here's one through the miracle of modern computer science. It's not really a miracle, it's just computer science. And also chemistry. The periodic table is chemistry. Draw, first of all, how many valence electrons does bromine have? I'll give you another 3.8 seconds. 1, 3.2, 3.7, 3.75. Time's up. Bromine, Br. This is the atomic number that tells you electrons, all electrons, but the valence electrons, you look at the top, Roman numeral VII is 7, which I also have in red, and therefore bromine has 7 valence electrons. Put the chemical symbol down, and now I'll give you some time to do that on your own first. Okay, time's up, and you have 7 valence electrons. You put a dot on each side before doubling up. I've got 4, 3 more to go. I'll start doubling up here. That's 5, that's 6, that's 7. And this is one way. Another way could have just as easily been this. And there are 2 other possibilities. 3 sides around bromine have 2 dots, and 1 side has 1. And doesn't matter which one you put down in the test, because good news, Dr. White knows his chemistry and knows that. So valence electrons, you show them by Lewis structure. Remember, this is now material for test 2, not test 1. Look out. We're about to get into the really good stuff. We're going to talk about chemical bonds. And see, Dr. White's real happy now because we're doing some really good stuff now. Now, When we talk about chemicals, there are two types of chemical compounds. A compound is a molecule or substance with two or more of the same or different atoms joined together. One is an ionic compound, and some books call it molecular. Dr. White calls it covalent, other books call it too, molecular covalent compounds. So you have ionic and covalent compounds. Oh, wait. I forgot. I think I warned you, Dr. White has the fastest mouse wheel finger this side or the other side of the Mississippi. All right. So we have two types of chemical compounds, ionic and covalent. I'll never ask you on a test what kind of chemical compounds are there, but I'll use this terminology in class. Now, I've used this term, and I'll never ask you on a test what it is, but you should know, what is a molecule? That's a group of two or more atoms that function as a unit because the atoms are tightly bound together. So if I say I have a molecule of water, and hopefully everybody by now knows water is H2O, I have two hydrogens, one oxygen, and they're stuck together and they function as a unit. If you look in this bottle, there's a lot of water molecules together to form a liquid. Remember the three states of matter: solid, liquid, and gas, and that's liquid at room temperature. But in this liquid, there is water molecules, two hydrogen, one oxygen. Actually, never thought of water as being a chemical. It is. Hope I didn't scare anybody. And another example of a molecule. Is sodium chloride, which you know as salt or table salt. And that's a molecule. The sodium and chlorine function together, are bound together, what we call a molecule. If you ever go out to breakfast, lunch, or dinner with a bunch of chemists, including Dr. White, one of us will always say, and I've done it so many times I forgot how many, can you please pass the NaCl? We don't say salt. Now, what force holds those atoms tightly together? And that's the chemical bonds. Oh, now I'm happy. So we're getting into the real good stuff now. And a chemical bond is the attractive force that holds atoms together in more complex units, which we call molecules. Now, I'll never ask you on a test what's a chemical bond, but I'll use that term this semester. And you should know that's the attractive force that holds atoms together in more complex units. So what holds the two hydrogens and oxygen together in water? Chemical bonds. In sodium chloride, what holds the chlorine and sodium together? A chemical bond. So chemical bonds hold atoms together in the form molecules. Now it's time for Dr. White to really scare you. Everybody, hopefully this isn't going to be painful. Touch your skin with your other finger like this, or if you're left-handed, by the way, I'm ambidextrous, go like that. Do you feel your skin? Those are atoms held together to make molecules that make up your skin. And that's chemical bonds are holding the atoms together in the skin of my hand and yours too And that's chemistry. Now, I could also say my hair, what's left of it, don't look, but anyways, your hair or my beard, those are atoms held together by chemical bonds. So is my shirt. My shirt is made of cotton, and guess what? It's atoms held together by chemical bonds. No, it's not that weird. It's chemistry. Dr. White likes chemistry, if you haven't guessed by now. But most people don't think of it as chemistry. They just go around and say, I hate chemistry. Did I tell you, my older sister, when I was very young, luckily my father, who liked chemistry, I wonder why I became a chemist. Don't know. But anyways, he loved chemistry. My sister barely made it through high school with a C. If it hadn't been for him knowing and liking chemistry, she would have flunked, but she didn't. And to this day, she hates with a passion chemistry. I love it. Uh-oh, I just drank some chemical, safe chemical water. So the force that holds atoms together in molecules, chemical bonds. There are two types of chemical bonds. Hint, know this, I'm being subtle again. And the two types are ionic bond and covalent bond. In any molecule of any substance, there are two types of chemical bonds. One is ionic bond and the other is covalent bond. And you should know this. So if we look at water, salt, or anything, there's a chemical bond and it's either ionic or covalent, and certain molecules have both. What is an ionic bond? What is a covalent bond? Good question. Thank you. Well, what is an ionic bond? It results from the transfer, this is important, one or more electrons from one atom or group of atoms to another atom or group of atoms. So, ionic bond, it results from the transfer of one or more electrons from one atom or group of atoms to another atom or a group of atoms. Hint, know this. If I ask on a test, and don't remember, this is material for test 2, not test 1. What is an ionic bond? And you can say that's the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Or you can put it in results from, either way. But ionic bond is the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. An example of a molecule with an ionic bond is sodium chloride. What's holding the sodium and chlorine together? An ionic bond. So ionic bond results from the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. An example of that is in sodium chloride. Ooh, here's another one. Now I'm going to really scare you. How many of you brush your teeth with, don't raise your hand or anything, but just mentally tell me. Let's see if I can get the message. But how many of you brush your teeth with toothpaste? If you look at the tube of toothpaste, you'll see on the ingredients list sodium fluoride. And sodium fluoride has this structure. By the way, I always get the O and U mixed up. Probably did it there too. But sodium fluoride, NaF, what's holding the sodium and the fluorine together? An ionic bond. Now, why is that in your toothpaste? Well, it turned out back and about, and I may be off by a decade, about the 1930s, they found this one small town in Texas that nobody had any cavities. Everybody's teeth were real good. And everybody, what's going on here? And they investigated everything about that, people in that town. And the one thing they found out was the water that they drank, municipal water, had a high level, very high level of sodium fluoride from the rocks in the local river or lake, wherever they got their water. And dentists experimented and found when they put sodium fluoride into somebody's water, or even better, toothpaste, it helps cut down on cavities. Unfortunately, it doesn't always work for Dr. White because I inherited bad dental problems, but I'm not going to talk about that. But sodium fluoride is put in there to give you better dental health. I guess that's the way of saying it. Look, Mom, no cavities. Oh, that was an old commercial. So next time you have a chance, look at the ingredients label of your toothpaste and look for sodium fluoride. That's chemistry too. So one type of chemical bond is the ionic bond. That results from the transfer. It is the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Now, there are two types of bonds, chemical bonds. The first one is ionic bond. The second one is covalent bond. And know this, what is a covalent bond? And a covalent bond results from not the transfer, but the sharing of one or more pairs. Remember, pair means two, of electrons between atoms. So a covalent bond is the sharing of one or more pairs of electrons. And what's an example of a molecule with only covalent bonds? Water. What holds the hydrogens and oxygen together in water? It's a covalent bond. Ooh, what's another thing that's held together? Right now, as you're inhaling, and I hope you all are both inhaling and exhaling, oxygen has covalent bonds. At the same time, in the air you're breathing, nitrogen has covalent bonds. Ooh, this is getting scary. And time for the piece de resistance. Your skin, my hair, your hair, my shirt. What's holding the atoms together? Covalent bonds. So, are they everywhere? Is chemistry everywhere? Yep, it is. And you should know, covalent bond, it results from the sharing of one or more pairs, remember pairs mean two, of electrons between atoms. So there are two types of covalent or two types of chemical bonds, ionic which is the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. That's an ionic bond. And then you have the covalent bond. Oh, I just drank some covalent bonds in my water. Think about that next time you drink water. Now you don't have to. But a covalent bond results from the sharing, or is the sharing of one or more pairs, remember pairs means two, of electrons between atoms. Now, there's a certain rule, and I've done this before, but let me remind you when I go click, will this be on the test? No, but it's important information I still want to talk to you about. So next couple of slides, click, I'm turning the switch. Will this be on test or the final? No, but it's something you should know to help you do other stuff that will be on test in the final. Now, there's something called the Octet Rule, and it deals with ions and other things. What's the Octet Rule? Remember, it switches off now. In both ionic and covalent compounds, atoms tend to acquire the electron configuration of the nearest noble gas. And we're talking about, when we say electron configuration, we're really talking about the same number of valence electrons. And how many valence electrons does the nearest noble gas have, or any noble gas? Well, let's find out. Oh, look, the last column of the periodic table, our noble gases, has 8 valence electrons. So all the other atoms want to either lose, gain, or share electrons. So it has 8 valence electrons. And that's called the Octet Rule. How many of you have ever heard a quartet? That means 4 musicians, and an octet is 8. So the octet rule is in covalent ionic bonds, electrons acquire by either losing, sharing, or gaining electrons to have 8 valence electrons. Now, when this happens, the valence electrons, certain arrangements are most stable. In other words, they don't undergo spontaneous change. Excuse me. I got a feather in my throat. Not really, because I don't have anything in my house with feathers. But anyways, that's cleared up now. The most stable elements are the noble gases, which used to be called the inert until somebody found you could sort of make them react if you really beat on them hard. And this most stable arrangement, and I didn't put NS2 NP6, which is 8 valence electrons, which is the outermost valence electron, where N is the shell number, like 2s, 2p, or whatever. Again, the octet rule in compound formation, when you make molecules, atoms, and the switches off for this, atoms of elements lose, gain, or share electrons in such a way that their electron configuration becomes identical to that of the nearest noble gas in the periodic table. And that's 8 valence electrons. Oh, look, how do you like I got real fancy with blue color? So what does this all mean? Well, let's talk about elements that could, remember, they want to get 8 valence electrons. And one way of doing that is losing some electrons. And when an element loses an electron, it forms what we call a positive ion. That's in ionic bond binding or bonds that transfer one or more electrons from one happens. And when an element loses one or more electrons, you form an ion with a positive charge. And that's called a cation. Oh, by the way, click, I just turned the switch on. Will this be on test? And you should know positive ion is an element with a positive charge. And it's also, and I'll never ask, but it's called a cation. How many of you have heard you should take a lot of calcium in your diet, either supplements or in the food you consume, to have strong bones? And so you don't get something like, which is quite sad, I've seen people with it, osteoporosis. I take a calcium supplements to make sure that doesn't happen to me, strong bones. But are you really taking calcium element? No. Let's find out what. But before that, let's look at the following. Now, how do you know what is the charge on a cation? In other words, a cation has lost electrons and has a certain positive charge. And thank you, Rain. Dr. White's a chemist, not a medical doctor, so there are a lot of things I don't know. But I can tell you, vitamin comes from the word, long ago they saw a certain type of organic compound, amines, A-M-I-N-E-S, were vital to life. And they shortened the word, instead of vital amines, they call them vitamins. I'll teach you more about that when we do a little organic at the end of the semester. Now, question would be, oops, sorry, promised I wouldn't write. And the question is, draw the ion for, in this case, it would be a magnesium. I can spell. How do you do that? Now I have one way here, but the best way is the following. Let's look at magnesium. The first thing you have to do is, how many electrons and protons does, excuse me, magnesium have? Well, you got to look at the periodic table. And magnesium, if you notice here, has 12 electrons, 12 protons. So I'm going to put that down in my paper. So magnesium has 12 electrons and 12 protons. Now, it wants to have the same number of electrons as the nearest noble gas. Well, how do we figure that out? Well, you look at the periodic table. Now, what's magnesium is at 12, numerically based on atomic number. I'll say that again. Numerically based on atomic number, what noble gas is closest to magnesium? Well, argon is 18 away. At 18 is 6 away. Neon is only 2 away, which is a smaller number. And hopefully I'll pick 2. So magnesium wants to have the same number of electrons as neon. How many electrons does neon have? Atomic number 10. So this wants to go to magnesium with 10 electrons. E is electron. You never change the number of protons. Now let's do some high-level math. There are 10 electrons and the charge on electron is -1. Remember, it's a minus charge. You have 12 protons. What's the charge on a proton? +1. I'll do the math. This is -11. This is +12. I'll add it up. What did I do here? Somebody should have caught me. That's 10. How did I get 11? Uh-oh. I think it's almost time for me to recharge and reboot my brain. Not really. But anyways, now you add it up. -10 plus 12 is a +2. Now I asked, draw the ion. How do you show that? You show it by the chemical symbol, Mg, and then to the right superscript, the charge. Now the old way, which Dr. White still likes, is this way. Or you could put the number first and then the charge. I like this way, but either way is correct. So magnesium has a +2 charge. Now, good news. Once you find out for one element in a column, you know them all, what ions. But let's find out if I'm lying to you. I'm not, but let's do the same thing for calcium. Now, first thing you have to find out for calcium, how many protons, how many electrons? Well, you go to your favorite periodic table and calcium, Ca, how many protons and electrons? 20. So calcium has 20 electrons and 20 protons. Now it wants to go to the nearest noble gas that's based on numerically of the atomic number. So here I am at calcium at 20. I go to krypton at 36, that's 16 away numerically, or I have calcium at 20 and argon is 18, only 2 away, which is smaller, 2 or 16. And time's up, hopefully I'll pick 2. So argon wants to have the same number of electrons, also valence electrons as argon, which is 18. So if we go back here, wants to have 18 electrons, but it will still have 20 protons. Let's do the math. Each electron is a -1, that's -18. Each proton is a +1, +20, add them together, and you get a +2. Am I done? No. When I ask draw the what ion does the element form, that means the symbol, chemical symbol, and then to the right superscript to charge. In this case, it's also +2. And you can draw it either way. I like this way. And that's what ion calcium forms, a +2. Now, when they say you should get enough calcium in your diet so you have strong bones, they're not talking about calcium metal. Calcium metal is hard like my ring, or do I have something else? I'm a railroad. This is a railroad spike that I got brand new. I like, and it's solid. That's solid. You're not going to chew on calcium is like this. Are you going to chew on that? No. You won't have any teeth, and if you swallow it, you'll be in serious problems. What do you really need to have strong bones? You need calcium cations, the +2. So next time you see something and says it's fortified with calcium, what they're really saying is they put in calcium +2 cations, and that's how your body gets strong bones. How? Well, I'm not a medical doctor. Ask your medical doctor. All right, it's time for you to have some fun. What ion does sodium form? And let me get the periodic table. And here it is. And why don't you try that? What ion does sodium form? Your turn. Have some fun. And when you're done, give me a thumbs up, please. Or any other emoji you want to use. All right, how many people want me to do this one? Because you may be having a little trouble. All right, I think just about everybody's done. So I better get to work. Now, how do you do that? First of all, you have to figure out how many electrons and protons does sodium have. Sodium, Na. We're talking about electrons and protons, atomic number 11. So sodium, Na, has 11 electrons, 11 protons. And what's the nearest noble gas? Well, let's find out. Remember, it's numerically. Now, sodium is at 11. If it loses an electron, it would have 10 electrons like neon. That's one away. If it gains a whole bunch, it'll go to argon, 18, which is 11 away. 11, let me try that again. If it goes to argon at 18, 18 minus 11, it's got 7. It's got a gain, which is a smaller number, 1 or 7. And time's up. Hopefully I'll pick 1. So it wants to go to the nearest noble gas numerically, which is neon. How many electrons does neon have? 10. So it wants to go to this cation with 10 electrons. You don't change the number of protons. And each electron is a -1. Each proton is a +1. Do the math. Keep an eye on me. I already made one mistake. -10 here, +11. When I add them together, this plus this, I'll get +1. So how do you show +1? When the cation is a +1, you don't need to put the number down. Sodium, that's a +1, and that's how you do it. Now, a number of years ago, I was looking for a new physician. Luckily, I joined near my house, and it's actually in the northwest suburbs here, a great medical group, Northwest Community group or hospital group. And at that time, unfortunately, I had to retire because of medical problems. I had a great doctor, and I went for my first physical with him. And afterward, and they took the blood test and all that, your blood pressure, check your heart and all that. He calls me up and says, "We've got to meet. When can you come in?" And I set up an appointment, and I love that. And his name is Dr. Cantor. And I now have another doctor, and she's very good too, Dr. Villarosa, who's just like Dr. Cantor. They've got some really great doctors in that practice. And he sat me down in the office, and he pulls up, he's got a computer and screen and says, "You've got problems." I said, "Well, yeah, I know I'm a little overweight." And he says, "You got high blood pressure. You got to bring it down." And a couple other things, which I'll talk about later, like high cholesterol. And he was very frank. And I love doctors who are straightforward, don't beat around the bush, don't play games. And he said, "Look, if you don't get this out of control, under control, some things, you'll be dead in 5 years." I said, "What?" He says, "Look, you're in the 95 percentile for having serious medical problems, meaning you'll die if you don't bring things under control. And one thing to get your blood pressure down is lower your sodium content you're consuming." And he's not talking about sodium metal. Sodium metal, if you eat it, you're going to be in the hospital because it'll blow up in your mouth. That's not good. Don't ever try that. But what he was talking about was the sodium cations. When a doctor says sodium, he means sodium cations. And where do you get that from? Sodium chloride is one place, probably the main place you're getting salt, sodium cations. And guess what? I like to be alive. So I followed his directions and went back, and I brought my blood pressure down. I've cut back on sodium and other things that were not good for me. And I'm still alive, and it's been more than 5 years, especially with the pandemic. Not that I'm supposed to bring religion into the class. So when they're talking about certain things in our daily life, we're not talking about the elements, we're talking about ions. And what I've taught you so far are the cations. Now, once you know one member in a column, you know all the others, what ion they'll form. So we just figured out sodium forms a +1. What ion does lithium form? Well, you can do the calculation like I just showed you, but since you already know sodium is +1, lithium is a +1. What ion does potassium, K, form? Well, you know that's a +1 sodium. It's in the same family. Therefore, guess what? It forms a +1 cation. Now, earlier on, we figured calcium forms a +2. What ion does magnesium form? You're right, +2. And that's cations. Remember, cation is formed when an element loses electrons. Now, the opposite of cation or positive ion is a negative ion. And negative ion is when an element gains one or more electrons gains one or more electrons, and an ion with a negative charge is formed. This is called an anion. Remember, positive charge is called cation. Ooh, that reminds me. How many of you have ever heard the poles of a battery or other things are called a cathode and anode? I wonder where that came from. Negative and positive ions. And if I look at the clock, it says, oh, it's time for a 5-minute break. I'll see you at 10:50, I'm going to go get up and stretch. And hopefully you do something similar. I'll see you in 5. Time to start again. I was looking out the weather window where I live, the Schaumburg area. There's just a very light rain, which hopefully will make a little heavier to make my lawn and bushes very happy, and me too. All right, we're talking about ions. Ions are where you either lose or gain electrons and form a charge on an element. And I did a positive and it can be a negative. And we're about to talk about negative ions. So when you gain an electron, you form a negative ion, which is called an anion. I'll never ask on tests what's a cation or anion, but these words have come into our daily life, cathode, anode, parts of a battery. And the question would be, say 3 points each. Chlorine. Well, how do you do that? Guess what? You use the same procedure I just showed you. First of all, you have to find out how many electrons and protons does chlorine have. Well, if you go to your local periodic table, oh, there's one on your screen right now. You look at the atomic number. This is not dealing with valence numbers. It's total number of electrons and protons. Atomic number for chlorine is 17. And that means chlorine has 17 electrons, 17 protons. Now it wants to have the same number of electrons as the nearest noble gas. Well, let's look at our periodic table. Well, argon is 1 away, neon is 17, and krypton is a lot more than 10. So which is small? 7, 1, or a lot more than 7 or 10? And the answer is 1. So chlorine wants to have the same number of valence electrons as argon. How many electrons does argon have? Look at the atomic number, and the answer is 18. So chlorine wants to get 18 electrons, but it will not lose or gain any protons. And now it's math time. 18, what's the charge on an electron? -1. What's 17? Because we have 17 protons. What's the charge on a proton? +1. Do the math. Keep an eye on me. I already made one mistake today. Quite luckily, but still. And -1 times 18 is -18. +1 times 17 is +17. If I add them together, what do you get? You get a -1. How do you show when the charge is -1? The chemical symbol and then a minus sign. And chlorine forms what's called the chloride ion. And that's a negative ion. How do you know? Because you look at the sign of the ion you write down. Let's do another one. I'll let you try one. I think you're up to it, I think. What ion does oxygen form? Oh, that's not what I want. That's what I want. So I'm going to let you find out first how many electrons and protons does oxygen have? Your turn. I'll give you a few seconds. I'm going to drink some water that has atoms in it. Time's up. How many electrons and protons does oxygen have? You look at the atomic number. That's 8 protons, 8 electrons. So I have oxygen. It has 8 electrons, 8 protons. It wants to have the same number of electrons as the nearest noble gas, numerically based on atomic number. So we need to go back to our periodic table. Now, if you look over here, what noble gas is closest numerically to oxygen? Well, it's at 8, neon is 10, that's 2 away. Argon at 18 is 10 away, and helium at 2 is 6 away. What's the smallest number? 6, 10, or 2, and hopefully I'll pick 2. So oxygen wants to have the same number of electrons, which will also give it 8 valence electrons, but now we're looking at all electrons, and that's 8 electrons, same as the closest noble gas, neon. I think I got ahead of you. I'm going to have to give you another one to do. So it wants to go to 10 electrons. You'd never change the protons. And now let's do the math. What's the charge on an electron? -1. What's the charge on a proton? +1. Do the math here. -1 times 10, minus 10. Do the math here. +1 times 8, plus 8. Add them together and you get -2. And how do you show that? This way, or now the newer way. I like the older way better. I just think it looks cooler. But you know, Dr. White tries always to be a cool dude. And that's the answer. Now, since I took away some of your fun, let me look at the periodic table for another one for you to do.
Hey, so I have a question.
I do questions.
Okay, so are we looking at, so you know how oxygen have 8 protons and electrons? So we looking at the valence electrons and not the protons and electrons?
Nope. Time out. When you're doing valence electrons, you look at valence electrons, which are number and top. When you're finding out what ion forms, now there's another way of doing it that I know how to do, but most students get confused. What does it mean when most students get confused? They don't get it right on the test, and they don't learn it either. And you want to get a good grade, so you want to get it right on the test. The method I'm teaching now that deals with all electrons and protons is pretty much foolproof for most students as long as you practice it. And I've been doing that for a number of years, and it gets the point across. There are other ways of doing it using valence electrons by how many electrons, going to an octet, but my way is, I wouldn't call it foolproof, but it's pretty bulletproof, and students, once they learn how to do it quite well. Does that help? Let me check the. Now, Colton asked a question. Certain atoms can go either way, and in real life, they go neither. They don't lose, and I'll get to that later on. Right now, I'm sticking to the elements that do form either positive or negative ions, cations or anions. There's something else too, but let's do another anion, and I'm going to be quiet and let you do this all by yourself. I'm running out of room here, so I'm going to go to my whiteboard. And why don't you try this one all on your own? I'm going to open up the periodic table. What ion, write the ion that nitrogen forms. And yes, I'm going to give you a hint. It's going to be an anion, but you have to show the chemical symbol plus the charge. Now I'm going to give you a whole minute to do this. See how nice Dr. White is? I see some people have already got the right answer, but I'm going to give everybody time to work it out. So please be patient. All right, I think everybody's done. Let's do this. Question is, what ion does nitrogen form? Chemical symbol for nitrogen is N, right here on your periodic table between carbon and oxygen. Three of my favorite elements on the periodic table. And nitrogen, you want to first determine how many electrons and protons does nitrogen have? And the answer is 7. Again, you're looking for all the protons and the electrons, all the electrons. And if I go back to here, I have my nitrogen. I have 7 electrons and 7 protons. Now, what's the nearest noble gas numerically based on the atomic number? Don't know. I got to look at my periodic table. And here I am at 7. And if you notice, neon is 3 away. Helium is 5 away. Where do I get this number? 10 minus 7, 3. 7 minus 2, 5. So which is closer numerically? And you could also say argon is way far away at 11, but neon is only 3 away, so that's the closest noble gas. How many electrons does neon have? 10. And neon, nitrogen wants to get the same number of electrons as neon, so it has 10, but it will still have 7 protons. Remember, each electron is a -1. Each proton, I didn't want to do that. Oh, what did I just do? Hold on. Each proton is a +1. Do the math. -1 times 10 minus 10 +1 times 7 plus 7. Add them together, you get a -3. How do you show that? The symbol, and then either -3, which I like to do that way, or 3 minus. Either way would be correct on the test. And that's how you do for now. One of your colleagues asked, why is it -1 and not -3? We're trying to find the total number of charges based on each electron. But you know, I had closed caption whiteboard, but anyways, each electron, oh, that was an awful joke. Each electron has a -1 charge. And therefore, what's the total charge from all the electrons? -1 times 10, using the method I'm doing. Now, there's another way of doing it without doing it this way, but this way is foolproof. The other way, students would be confused and get lost, which is not a good thing if you're a student or an instructor. So this is the way I teach it. And does that answer your question? Whoever had the question, why is that? Theo, that's why it's -1, not -3. Now it adds up to -3, and that's how you get this. And that's how you find ions. Now the question is, Dr. White, why are you teaching us this stuff? What good is it? That's a good question. Remember, all questions are good questions in my class, in my universe. So why am I teaching you what ions will different elements form? Let's find out. And that's because when we talk about ionic compounds, which deal with ionic bonds, they deal with transfer of electrons. Remember, for ionic compounds, atoms can donate electrons. Other atoms, where those electrons go that they donate? To other atoms that accept that. When such an electron transfer occurs, then positive and negative ions attract one another, forming an ionic compound, which is also called an ionic bond. How many of you have ever heard opposites attract? Well, that happens in chemistry too. Positive and negative ions attract each other, and that's how you form the ionic bond. That reminds me, my best friend and his wife are total opposites. And when they first told me, we're getting married, I'm thinking, oh, what's going on here? They're so opposite. How can they get along? I mean, they're really opposite. And guess what? They've been married, let me do the math, over 40 years now. And they're still very close. It's a beautiful thing to see. And they're still opposites. Sometimes they get upset at each other because of their opposites, but not that upset that it has an effect, it's affected their marriage, which is, like I said, a beautiful thing. It's been that long. And I'm really blessed because my best friend I've known a lot longer than since he's been married. And that doesn't always happen, but I'm also close, very close to his wife too. She's also now my best friend, a very best friend. Not like her husband, my best friend, but we're quite close. And we're sort of like family together, which is nice. So when we talk about ionic compounds, negative and positive negative ions are held together with strong electrical attractions, opposites attract. How many of you ever played with a magnet? It's like magnetic force, but it's not magnetic. Or better yet, have you ever taken a magnet and gone whoop, to a piece of metal? Dr. White loves magnets. You can't see them, but I got some on the side here. And I just like playing with them. I got some toys. Oh, here's one. I haven't played with this in a long time. And this is, each one of these balls is a magnet. And it's a very interesting puzzle to make different shapes and then get back in that cube, which is quite challenging. But anyways, I don't make it anymore because I guess little children were swallowing these, which is not good, but I didn't. So if we look at ionic compounds, there are positive and negative ions held together. And let's look at a real quick example. We learn sodium forms a +1. It gives up, or better yet, let me do this. Sodium, as you found out, loses one electron to form a cation. Where does that electron go? To chlorine. Chlorine, chloride ion, gains one electron to get the same number of electrons as the nearest noble gas. And the sodium looks at chlorine and says, oh, I've got a plus charge, you got a negative charge, but you didn't know atoms could talk. They can't, no, not really. And they form sodium chloride. And that's an ionic compound because what holds the sodium and chlorine together? Ions. It's an ionic bond. And think about it. The next time you're out with friends, neighbors, or loved ones, and you see someone putting salt on their French fries, you can say, no, not that, but getting all choked up over this good stuff. You can say, do you know that sodium +1 cations and chloride -1 anions held together in an ionic bond that you're putting on your French fries? Don't do that. You'll lose a friend, neighbor, or loved one real quick. People don't want to hear about chemistry when they're eating. But next time you use sodium chloride, think about that's cation, sodium plus, anion, chloride minus, held together in an ionic bond. Now, switches off for this slide. Interesting thing about ionic compounds, they have very high melting points. If you notice here, 500 degrees C, that's almost 1,000 Fahrenheit. This is almost 4,000 Fahrenheit. That's much higher than my oven goes. My oven doesn't go to 100 F or 500 C. They conduct electricity when they're liquid, or you put them in a solution. I'll teach later on what a solution is. And they consist of ionic atoms or ions bonded together. Ooh, let's take a trip out into the real world. If I can find it. All right, where'd you go? There we go. See a question before I. All right. Now, I'm going to have to ask my thumbs up people. How many of you see on your screen the Wikipedia for sodium chloride? Come on, thumbs up people. Thank you. All right. Now, I might have mentioned it, and I think I have, but I'll mention again. Wikipedia has been so heavily policed by chemists like myself that it's been a number of years since I've seen anything, I'm only talking about chemistry, that's been incorrect. Now, here they have the entry for sodium chloride, and when you go to Wikipedia, they have a lot of neat stuff. If you look on the right-hand side, has names and other names, common salt, table salt. And then it has identifiers, which I'll skip. And then it has properties. And these are important. Oh, you learned about density. And here is the melting point of sodium chloride, which is ionic. And it melts at around 800 degrees Celsius, which is 1,473. Let's not forget about 0.3 Fahrenheit, which means it's got a very, very high melting point. Just for reference, water, which is not an ionic compound, is a covalent compound, melts at 0 degrees C, 32 degrees F. So ionic, oh, let's do one more. This is fun. Oh, someone asked, is liquid sodium chloride reactive with water? And the answer is, I don't know. I've never done that. It's not a branch of chemistry I've done. So, Dr. White, I better talk about something right now. To myself and to my students and anybody else, I don't know the answer. I'm not going to BS you. You know what BS means. I'm keeping it clean. I'm not going to tell you something that's not true, because if I don't know, I don't know. And guess what? I don't know everything about everything in chemistry. Don't get upset, but I don't. I do know a lot. And I'll look it up and I'll find out. I'll try and get back to you tomorrow or Monday. I've been real busy. I got labs to grade. Don't forget, you should hand in your lab yesterday for the safety lab. It was due. Make sure you upload it today, or otherwise you'll get 0 points. All right, we're looking at sodium fluoride, and sodium fluoride is found in drinking water. When they say fluorinated water, which Chicagoland has, they put some in. It's also in your toothpaste, very little, but enough to make a difference. And notice dental caries. I'll let you read this in your at your own leisure. But if we look over here, properties, what's the melting point of sodium fluoride, NaF, 993 degrees Celsius, which is 1,819 degrees Fahrenheit, which my oven doesn't go that high, and I know yours doesn't. And that's the neat thing about Wikipedia. You can find a lot of interesting information about chemistry here. So the switch is off, but here's some properties of ionic compounds. I just wanted you to be consider. Now, when we talk about ionic compounds, by the way, click, switch is on. When we talk about the formula of ionic compounds, something like sodium chloride, why is there only one sodium and one chloride ion in sodium chloride, NaCl? Please pass the NaCl. Why not 5 sodium and 7 chlorides or something else? Well, this indicates the number and kind of ions. And the most important thing I will teach you today, one of the most important, is the sum of ionic compounds in the formula is always 0. Another way of putting it is all molecules let's spell it right. All molecules, and this is very important. I think I mentioned when I was a student taking notes in my notebook, in the left margin, if it was really important, I'd start putting stars, or once later on, I started putting know this. But if it was really important, I put stars and IMP and an arrow, know this. That's an ugly looking arrow. Let me. That's better. All molecules have a net 0 charge. There's no exception. If you find an exception to this, let me know. We'll be rich beyond my wildest dreams. That goes beyond having my own Ferrari and Lamborghini, my own jets to play with, and my own island in the South Pacific. It goes beyond that. Why am I saying that? Because you'll never find an exception. All molecules have a net 0 charge. So what does that mean? The scripts in a formula, the formula of any ionic compound has a 0 overall net charge. And the subscripts in a formula are used to obtain a 0 overall charge. And what does that mean? I'll never ask you this slide in the sense of writing it on a test, but let's show you how you apply this. Again, all molecules, and this you should remember, I'll never ask on a test, but it's that important. All molecules have a net zero charge. It's so important. I'm going to say it once more. All molecules have a net zero charge. So what does that mean? When you're writing ionic formulas, the formula for a molecule that's made up of ionic charges, the continuation of concept, that's the subscripts of the formulas, are used to obtain zero overall charge. What does that mean? Let's take a look at this. Sodium, oops. Sodium has a +1 charge. And chlorine has a -1 charge. This always adds up to 0, always, in any ionic compound. Therefore, we have 1 sodium, 1 chlorine, and it adds up to that, and that tells us sodium chloride is always NaCl. Why not Na2Cl1, 1 chloride? Well, if you had 2 and each sodium has a +1 charge and each chloride had a -1, would that add up to 0? No. So that's why you're never going to have 2 sodium, only 1. Let's look at another one. I'm writing again, bad Dr. White. Sorry, I wrote this as AND. So the question is 3 points each. Write the formula for the molecule made up from calcium +2, I got to do that right, and chloride -1. Well, how do you do that? All calcium is a +2, calcium cations. All chloride are -1. This has to add up to 0. Does it? No. Well, you can't change the charge. This you can't change. But you can change how many of them. Well, this is a +2. How do I get this to 0? This has to be a -2. I can't change the charge, but I can change how many. Now, if this is +2 and 2 times -2 is -2, now it adds up to 0. So what does that tell us? In calcium chloride, there's 1 calcium and 2 chloride anions. And that's the formula for a molecule made up of calcium +1 and chloride calcium +2, chloride -1, CaCl2. Now, it's nice to find out about chemistry in our daily life. Where do you find calcium chloride? Well, this last winter, if either where you live, or in my case, I own my own house, they had ice on the sidewalks and the driveway of my driveway to my garage, and super cold, sodium chloride won't melt, the rock salt won't melt that ice. You need something else. And you know those little white pellets you can get at your home improvement store, like Home Depot, Lowe's, or Menards. I don't get any money for saying that. I wish I did. How do you get that? Well, that's the calcium chloride. And I'll teach you later why that melts ice at a lower temperature than rock salt. But what's the chemical structure or formula of calcium chloride? CaCl2. That's because all molecules have a net zero charge. And let's do another one. Let me go to my whiteboard. Do the same thing for Na plus and F minus. And I've got to go blow my nose. I could get some Kleenex. I'll be right back. I'm back. And my nose is nice and clean. Anyways, what's the formula made up of sodium plus cations and fluoride minus 1 anions? And that's this. Oops, that's not what I want. And sodium is a +1 and cation, and fluoride is a -1 ion or anion. Does that add up to 0? And the answer is yes. So the formula for sodium fluoride is that. All right, a couple things. First of all, on tomorrow after lab, stick around for those who want to. I will teach the method how to eliminate test anxiety. Now, one of your colleagues just asked, Jada just asked, how do you know what's negative and what's positive? Well, remember earlier today, I taught you how to determine what ion is formed. And you look for what's the nearest noble gas. That's one way. But also, don't tell anybody I'm being nice. On test, the problem, like I just showed you, I would show you the different ions, and then you'd have to figure out how to find a formula like I just did. And that's how you do it. Hopefully that explains it. And we'll remember this is test 2 material. right now you're thinking about test 1, but when we get into that, I have practice problems in Blackboard for you to do, the exact things. And by the way, after test 1, you will really understand why I call them practice problems. Hint, hint, wink, wink, say no more. I think it's wink, wink, hint, hint, say no more. That comes from Monty Python and the Flying Circus. If you haven't seen those, you're missing one of the funniest television shows that ever was on television, period. But anyways, don't forget about Thursday. Don't forget the density lab that you need to use beyond Lab Z is due tomorrow. If you're having problems with beyond Lab Z, come to my office hour tonight from 6 to 7:15. I'll help you out. Guess what? I can share things like I've seen my slides, and you saw me do yesterday on Zoom. Go to Beyond Lab Z and have fun putting the sodium in there and other things. I can do that with you tonight if you need help. And if I look at the clock, we got a minute or two more. Any other questions before I might let you out a whole minute or two early? Any questions? And also, if you haven't, and some of you haven't, make sure you upload as soon as possible, ASAP, the signature sheet agreement to Blackboard. That's in the assignment area. Make sure you upload that, because if you don't, you can't take test number 1. Or if you do, I'll give you a 0. And with that, I'm going to end up a minute or so early and say, move the pointer out of my face. This too, say, Gang gesund. Oh, somebody beat me to it. Be healthy. Remember, Gang gesund is Yiddish for go with health or be healthy. When I was young, my grandmother who spoke Yiddish, my grandfather too, and I learned some, my parents did, but not that much, would always say when I left, and my sisters and parents too, Gang gesund, I'll see you soon. And I'll say, Gang gesund, I'll see you tomorrow. Bye.